Hello, grade 10 science students. So last class we finished up our biology unit. Today we're going to start talking about optics. And this unit is literally talking about light and how light works and the physics of light. So we've done our chemistry unit, our biology unit, and now we're going to do our physics unit. So let's talk about some simple facts about light. Life on Earth is possible because of the light from the sun. It heats the earth for one, so it gives off some sort of radiation as heat, but it also allows photosynthesis to occur in plants. And you have to remember from our grade 9 science class that plants are going to be the majority of the ecosystem. Without light and without photosynthesis, our food chain would collapse. Okay, so if we didn't have plants to be those primary consumers, our food chain would collapse. Light travels at a very high speed. It's 3.0 times 10 to the power of 8 meters per second. So every second it's traveling that fast. It would take an object moving at this speed of light 1 second to circle that Earth 7.5 times. And light travels in a straight line. And if something's blocking it, then that's how we get the shadow. Okay, so your shadow is an evidence. It's what we would say is evidence of this. So those are some fun facts about light, but let's actually talk about what light is. So the nature of light. Light is a medium, which means that any physical substance through which energy can be transferred. So heat traveling through a metal spoon by conduction, hot air currents traveling through air by convection. Okay, these are all mediums. Okay, they're passing that energy through or transferring that energy. Light is one form or the only form that can travel without a medium because we do it through radiation. Light is going to behave like a special kind of wave, which we call an electromagnetic wave. And what this means is that if you imagine how waves move in the water, so like on the Georgian Bay, or if you have a smaller lake by you, or even in the ocean, that water, that way that energy is transferred in those moving waves from one place to another, that is how our electromagnetic waves behave, okay? And what happens here is that particles are moving up and down, and that up and down motion is what causes what we call these transverse waves. Let's see if this will work. I'll make sure to post these links in the Google Classroom or actually on that Google Doc with everything else. So there's a couple of things that we're going to be able to tell here, and I'm going to be upfront with you guys like I usually am. There's going to be some math in this unit, and I promise to make it as simple as I can. Remember, I am also a math teacher. I will walk you through every step. One of the things that we can calculate is how long the wave is. And so we call this the wavelength, and we calculate this from crest to crest or trough to trough. So this is the crest, the highest point. So we'd calculate the wavelength from this point to this point. Okay, that's one wavelength, or from the trough, which is down here, from here to here. And we'd be consistent. So you would never calculate the wavelength from trough to crest. That's not a full cycle, as you can see. So I'm really calculating how long it takes for me to return to the same spot. Electromagnetic waves are more complicated because they involve electric and magnetic waves at angles to one another. So remember that we talked a little bit about electromagnetic waves in grade 9 science. So what's happening here is there's actually two waves interacting. So you have your electrical field, which is going in the y axis. So my vertical axis going up and down like this. But then I also have my magnetic field, which is going from side to side. Okay. What does this mean? Well, this means that we had to kind of devise this thing called the electromagnetic spectrum. And I'm using we very loosely. Obviously, I had nothing to do with it. People who are way smarter than me in the world did this. And so the electromagnetic spectrum is basically a diagram. And I took this right out of your textbook that shows us the range of electromagnetic waves. And it does this in order of wavelength or energy. So you'll notice that as we move across our electromagnetic spectrum, we're going from a small amount of energy to a large amount of energy. And notice that as that happens, our wavelengths become shorter and shorter. So in radio waves, they're super spread out. Do you guys see this? And then as soon as I hit microwaves, well, that's a little bit more energy. They're getting closer together. Those troughs are getting closer and closer. Infrared light is even the same. So those crests and troughs are getting kind of squished together, kind of like a slinky. And then we have this little tidbit of visible light, that small spectrum there. Ultraviolet light gives off a ton of energy. We can't see it. X-rays, enough energy that we can actually take a picture of our bones. And gamma rays, just like in the Hulk. We can remember the order of our electromagnetic spectrum by this little mnemonic that we have used. So, Raging Martins invaded Venus using X ray guns. Okay. And this stands for radio, microwave, infrared, visible, ultraviolet, X ray, and gamma rays. Essentially, what we just talked about is that the keynote here is that the shorter the wavelength is, the higher the energy is going to be that it gives off. And I actually will post this textbook page on the Google Doc and its common uses for each of the categories of electromagnetic waves. So, for instance, like I said, we talked about X-rays and how those are used to help us in the medical field. Okay. I like this analogy in terms of things that we can see. So we can't see wavelengths. That's not something that we're able to do with our eyes. But if we could, it would be the same size or the same comparison as a football field. And then microwaves are between humans and insects. Infrared is between the point of a pin and human cells. Our visible light, so the colors that we can see, that's like a protozoa, a single cell. Ultraviolet are like molecules. X-rays are like atoms. And then it goes into atomic nuclei and subatomic particles. This is how small they are in comparison. Okay. Our visible spectrum is basically just the range of wavelengths that we can see with the human eye. And we see these in terms of color. Okay, so we can see these with our red light all the way up to purple. And as soon as you notice that purple is a smaller wavelength. As soon as you drop off there, then that's going to be ultraviolet light. And we know this because we can actually use prisms to separate white light into the 7 colors. And this is how that happens. It slows it down so that it's able to have that separation. Okay, so if this is white light, then it separates. Okay, so this is basically what light is. I'm excited about this unit. It is really fascinating. I love physics. I'm actually in a physics course right now. So I'm excited to share it with you. Send me an email if you have any questions. I'm posting your homework questions. It's not going to be 1 to 10. That's a lot of questions. This was if I was teaching, like if we were in the classroom. So I will fix that. So just watch the Google Doc to see how many questions you should do. The textbook pages are there as well. Miss you all.